Welcome. This is the last session for today, right? I hope I can give you a good, story after this one. So we will talk about augmented OLAP for big data. So what is augmented? I leave a question here, and we will answer later. I'm Luke Han, co-founder and the CEO of Kyligence, and also the Apache Kylin PMC chair. And we also Strata, global sponsor. So if you have time, please go our boss to talk with us, our engineer over there. So a little bit of myself. About like 5 years ago, the team we work for eBay, we created the Apache Kylin project and open source data, and soon it become the Apache Incubator project. And we, now we have like a lot of adoptions over there, and so we have been recognized by the industry very much from the beginning. So you could see like the Info Award. We have 2 years award for the best open source software. I would like emphasize for the 2016 one, we be selected with like a TensorFlow among with like the 10 best open source over the world. And now we have over like thousands adoptions all over the world. Many giants over the world, they are using our technology to help them to build an analytics layer on top of a data lake, Hadoop or something else. For example, like from France, the Delcom, they just build a system on top of that, and also like a Walmart, and also other like a lot of bigger companies in China and in US. Okay. So today I was talking about a little bit about things is the pains of big data analysis today. What's the biggest pain we have now? And later on, I will introduce our solution. We call it augmented OLAP. And we have a video and also a benchmark to see how we can better than other like technology and can speed up for the performance. And finally, I will share 2 use cases from the financial services. It's a very huge one, and we can talk about that one. So a little bit about the company itself. The team is actually the original creators of Apache Kylin, and we formed this startup 3 years ago, and we raised the first funding from Redpoint and Cisco, and then we raised our Series A from CBC and Sunway, and last year we raised our Series B about like $15 million from Fidelity International. And we just closed our last funding about like $25 million from Co2. Okay, just closed the last week. Okay, and we operate globally. So now we have an office in like China and also in US. And soon we will have a branch will be in Europe. Okay, and talking a little bit about the customer. Okay, those are like paid customer. Okay, so we are mainly focusing in the financial services, manufacturing, telecom, and retail, and other domains. So you could see most of them are actually global 500 companies, and their use case is really huge. Like most like the 100 terabyte to like a petabyte data size. It's very, very huge, and serving like hundreds, thousands of users nationwide. Okay. And also we have a very great ecosystem with all the global vendors, partners. So we have like upstream and downstream. So we can run any like Hadoop distribution from like Cloudera, Hortonworks, MapR, and also we already certified with most of the BI tools like MicroStrategy, ClickView, Tableau, like Power BI. By the way, like Power BI, they shipped it our data connector from last year's release. So if you open the Power BI desktop, you can find our connector over there. Okay, and also we already deployed to most of the cloud vendors already. So you could find us from Azure Marketplace or the AWS Marketplace. It will coming very soon in this month, and also the Google Cloud, and also like Ali Cloud in China side. Okay, so you could see we already worked with them very well and certified it for our upstream and downstream. So it is a part of the entire big data system. Okay, so before I'm talking about the pains, let me ask you a question. So I like to take Photoshop very much. Okay, so my question is how you can take such a Photoshop photo, right? it is not easy for you to take such a photo because it's a darker environment. You have to find one, we call the professional devices and know how to turn such settings, right? But are you really know that? How many people know how to turn those buttons? I have totally no idea, I have to say. How you do that? So today, the technology evolution, it will bring a convenience for people to do that. So today, you do not need to be an expert. It's very easy. For example, using this phone. Okay, by the way, Huawei is my customer. So let me do advertising now. So actually, I bring this P3. It's very, very great. Using AI can help you to automatically to tune that settings for you, right? So now you are expert, but you do not need to know anything about such settings, right? You already mastered all the photos. That's the first thing changed a lot. The second thing is you will then, everybody has a smartphone, right? I take hundreds of phones every day. So my God, I have thousands photos now. How you manage that? How you collect that? Right, the problem. So we have a very great stuff is now you can using a Google Photos. It's very good. If you type a dog, okay, it will pop up all the photos with the dogs, right? Think about that. If you select by yourself, how many times you need to do that one, right? How you can organize all the these photos by yourself? It's impossible already, right? Because you have too much of the data. So this is for the personal side. So you need something new to help you. This is called AI-augmented. It helps you a lot, right? You take 10 photos, but the machine can recommend the best one to you, right? And also, if you want to try to combine something together, it can automatically create something for you. You do not need to be expert. You do not need to know the final cut or something, right? So that is the power of AI, the power of machine learning, something to impact our life. So the question is, then how about your enterprise data? Your enterprise data is bigger than your personal data, right? It's very huge. And where's your data? How you do that? Who will create the reports? And how to answer your boss's question just in seconds? And ask your question. What's the process inside your company to processing that one? This is a challenge we have today, right? This industry, we call it the data management industry, right? The data management and analytics industry, but it's very, very old. It still requires a lot of human efforts. So what's the idea we can come up? So people come up for this idea. They're scientists. Well, it's nice. So, but I don't believe this way. It's because, it will require a lot of things, right? Previous, you require a team. Now, you say, hey, I need a scientist. And then that scientist will learn Python, will learn R, will learn Scala, will learn Spark, and will learn the data, will learn the application. Oh my God. Really? It not works, I have to say. So I found this a very interesting way. Okay. So you are thinking, you are very cool, for the data scientist. But what's your really job you are doing today? Most of people are actually circle monkey, right? So it not works, I have to say. So what's ours? So the question is, your analytics demanding is changing very fast and every day and everything. But it's very slow and very heavy for the operation itself. And plus, you need an experienced data scientist, right? Where you can find those people? It not make sense. You cannot find enough data scientists for your organization. So here is a way, right? Here is what the reality is. When your business user come up with one requirement, they will go to the analyst and then ask the data engineers to do the project. It will take a long time. It take a lot of steps to build such a way, right? But this is we call it is the paying for slew in some people approach, right? So it's slow time to value, it's collaboration, it's resources, and a lot of things you have to find someone to familiar all of them. So you need to find someone can know what's the the pros and the cons of like Impala, SparSQL, or Drill, or something else, right? And pick up a right tools for you. But it will take a long time for him to learn such things, right? So that is a pain over there. So what's our solution? So our philosophy is this. We think we should using machine to automate all the stuff, to replace such heavy job, to delay our analyst without a lot like hundreds of people behind of him, right? Using machine to do that way. Okay, so we'll become in this way. So we will introduce we call it augmented OLAP layer, and sit on top of like a big data stack. So we will introduce semantic layer. We will do the automation. We will acceleration that analytics, and we offer like a governance. So those things you can be managed by a system itself, and release a lot of human efforts to do the routine work, right? So this is our philosophy. So how we do that? Let me show something and show a demo. Okay. So yeah, here is we call it a learning OLAP system, and here is the way. So we just open the interface to the analyst, to the business user, and we plug it to any like source, and then let the user to do that analysis, do that job. Okay, at the first, it will be slow, but we will capture all the SQL history, we will capture all the users' behavior. Based on those things, our machine learning engine will recommend a lot of things. Can to recommend a right data model for you, can to help you to bring the data from like Greenplum or Oracle to Hadoop, even to the cloud, without any code, without any like knowledge about those way. It can totally done by the machine itself. So this is our philosophy. Let the machine to do the dirty job, but let the people just focusing their analytics side, right? So this is the philosophy we behind our system. But the question is, then where are the analysts? Where are the data scientists? Where are the administrators? Okay. So actually they were behind of that. So those people will not be a dependency. They will not be a bottleneck. Right. They will sit on beside over there to talking to the business table at the same level to do the governance, to do the management. So that is a way can help a lot, to speed up for the analytics and serving the faster changing in the business. So let me give you a demo about how this system works. Okay. So first we will using 1 billion rows of sales records. It is actually generated from TPC Edge. And we will use Tableau to serving our favorite BI tools for our analysts. And I will introduce how this backend stuff works. Okay, so let me go to a video demo. So first, I'm not sure. Oh yeah, okay. So it will be very slow, but people, an analyst, they will using Tableau to talking to our services. Okay, those services contains 1 billion rows. Okay. So they can do anything they want, right? That is a business. This is analytics. So like this is the revenue, and do whatever they want to do. It will be slow. So let's see that. Okay, we'll take about 10 seconds and to get that data to ready. And this is using the SparSQL, the SparSQL 2.4 version. Okay, then the analyst will doing a lot of ways. So the first challenge is he's very unhappy because every action it will take many seconds, even minutes. And here is we also call this is a training phase. What's that mean? So if you go to a business user, hey, what kind of your analytics? What kind of your dimension and measures you want to have? Most of the answer will be, oh, I need everything. Right, and they cannot give you such scenario. They only want to say, hey, here is a dimension. Do you want it? Yes. Here is a measure. Do you want it? Yes. Do you want to? Could we remove that? No way. So finally, you build a very, very huge data, but nobody uses that. And nobody knows how your analysts deal with such like data. But now we have this phase. We will capture all the like SQLs at the back end. So we know about the scenario. We know how they analyze that data, right? So let's say, okay, they're still working, still well, take a long time. And let's see what can happen later. Okay, so yeah, it's good, right? But take a long time. Let's just move to the next one. Okay, so you can see most of the query engine will like about like 10 seconds. Okay, so this is from the Tableau's query performance. Then let's see how we can to do that. Let me stop here. Oh, sorry. Oh my God. Just 1 second. Okay, here is the backend, the SQL history. It is analyst behavior, right? So you can see we capture all the stuff, and now it's very easy for us to do the augmented. We call it the rule-based engine. So that rule-based engine you can automatically set, say like the latency. Like bigger than like say 5 seconds, we should to speed up, or like the SQL from the like boss, the CU side, we always want to speed up, something like that. We call it a rule-based. And once those things those SQLs come into this engine, we will filter that, and then the things will happen now. Okay, let's just continue. Okay, just select those one and. One click, it will generate a job. This job will, you can see, let's see that job. Okay, it automatically load. And load the data. Here is two things happen. The first, we will pull the data from SQL, from source. Actually, we can support like Oracle, like a Green Prom, like a SQL Server, something else. And after that, the two things will be speed updated. It is automatically done. And then the same Tableau reports, nothing changed, okay? When you are play as the same way, or it's just in seconds. And this is done. We migrate the data from your different source, right? The second is we speed up for that one. The third one is you can expose this to more users for yourself. So this is value, we call it augmented. It's a very basic concept behind of us. Yeah, we will do more beyond that. Based on the usage, based on the like how frequency of the user, we will do more optimization for the customer side. Okay, so this is what we have, and you can see now it's very, very fast. And plus, it can serving like thousands or 10,000 concurrent users. It's very easy to do this way. Okay, so let me continue. Okay, so there are several questions. Yeah, this will looks good, but how about the first time? Right, the first time always will be slow, right? So there's a different ways. One way is you can generally collect most of the scenarios or the existing SQLs to us. Let the machine to learn first, or we have an expert model. So you can ask an expert to build the fundamental data set for the analyst or for the user, right? They can help to prepare for that way. In that case, it will always can come in very fast. So the second question, the challenge is, well, okay, looks good. If we have like those like hundreds SQLs, it will be accelerated very much. But how about our new SQLs? It will be different dimension and different things, right? So our engine will learn from those like model, and when they build such like a way, it will be a generic way. So if we already contain like a star schema model, we will bring most of the data in. In this case, it can then any SQL within this data model, it will be very, very fast. But other SQLs not hit like this model, we can do a little bit like a push down, and once this push down ready, it will also cache that data in our cache layer. It also we can speed up. Okay, so this is what we can help at the beginning. And in that, we call it the training phase. Right. You can ask your analyst just to do that job, okay? But tell them, okay, for this week it will slow, but please use it, okay? And after that, the system will kind of do construction and at the end behind of that, and then can to prepare for something. And next week they will happy for that, right? And another way is how about very comprehensive, cycles? Okay, this is looks like someone like jogging a job, right? But how much complicated we can support. So we do a benchmark using a TPCH. So most of the people I know the TPCH, right? We can answer a very complicated queries regarding to this Snowflake data model. And we done a POC. So we using the same same like data set, but we generated two data sets. Using a different scale factor. The scale factor is it will indicate how big that data is. Okay, so this is how many the data is, the billions rows. Okay, we have done a lot of other like benchmark now. So we're using the same cluster and the same configuration in the out of the box to compare. The Spark SQL and all the setting is the same. Okay, that's totally same. So what's the result? The result is most of our queries will below than like, from here, it might be like 5 seconds, right? But the worst case for us is just about like 10 seconds. But compared to like a Spark SQL, it will take like 50 seconds or minutes, right? And this is by default the setting, yeah. So this is the way. And another thing is you could see the different sector. That means the different data size, right? We always keep the flat in the latency. Yeah, it is unfair because we do a pre-calculation. We do index, right? But your analysts don't care. Your analysts always wanted to have such like a performance on their finger, right? But you could see for any like MPP stuff, they will always like scale up. Okay, so this is a setting, and also this is how many acceleration rate compared to Spark SQL. So you could see most of them we can accelerate them 10 times than that one. But we are not saying we will replace that one. Okay, we always would like to say we are accelerate that way. So we are not an ETL process or not a landing phase. So you should landing your data to like Spark SQL or Hive or somewhere, and using us to speed up that one. So that is we call the OLAP. Right, so we call it OLAP for big data. We are not seeing a SQL for big data. Right, so that's different. Okay, so Spark SQL have Impala or like Greenpron, like Oracle, like SQL Server, MySQL, Postgres. They also, or like Redshift, and soon we will support Snowflake. Could be our input source. So we will pull the data from over there and build the OLAP stuff, and then can serving for the for the analytics side. Okay, so here is the conclusion. So it is our architecture. We call it is a AI-augmented analytics platform. So we will read from the SQL history. We will learn from the analyst behavior. We will know your data logs and the data profiles. So we will have a machine learning engine to dig into your data model and recommend it to you. And also we were using like the Apache Kylin Cube. That is the open source one, right? But it is our core engine. And also we have a learned index. That means we will learn from that SQL's history to know how to build that index. You do not need to build by yourself. This is the case. And also we have like a smart push down. So for those like SQLs, we cannot answer directly, so we will push down to the source. Okay, and once those SQLs be captured, so our load-based engine will to do this cycle again, right? Then it can serving for any like a BI or reporting usage. We can consume data from like a Kafka, so you can support like a real-time analysis, or since we are actually a read-only system. The OLAP is a read-only, right? So it can serving for a high performance and high concurrency. So some of our customers, they are using us to build their data as a services. For example, like Yahoo Japan. Yahoo Japan leverage us to build a machine reporting system open to every their machine. It is an online analytics platform. Previously, they are using like Impala, but most of the report will be answered more than like 1 minute. But when they are migrated to us, just can be answered in just seconds. And another case is from an internet company. It is for OTA, the online ticket agent application. It is from the mobile side. They build one services behind over that. And when people open that application, it will read the data from that services and serving for that analytics. So that's something we can do. Okay, and we can deploy from on-premise to all the cloud vendors. And now the container side is on construction. We will support the Kubernetes as a deployment. This will be introduced in the next half year. So we are on the construction now. Okay, so yeah. This is another one. So let me talk a little bit about the use cases. I just introduced 2 use cases. The first is from the China UnionPay. The China UnionPay is something like Visa and MasterCard, right? But their transaction numbers already beyond the Visa. So their transaction number is already top 1 of the world. So this is a lot of people, in China, the population is very, very huge, right? And the people, to do a lot of shopping and setting something else. So previous, they using IBM Cognos. They built that analytics platform over 10 years. At the beginning, they are very happy. But finally, they find that there are two limitations. The first, security. They cannot support the cell level, setting. So they have to create the different cubes for different, province, the regions, right? And considering China is so big, so they have to repeat that more than 30 times. Okay, firstly. The second is for the limitation about dimensions. They cannot contain data over 12 dimensions. So they only can roll up for a very high level, view for the cube for user, right? And they cannot talk to the big data very well. So last year, we worked together and we replaced 800 Cognos cubes just with one of our cube. This is a replacement. The benefit for them is they do not need to manage thousands of cubes now, right? And also, previously there are more than thousands ETL jobs. So you could think about how complicated it is. Now, just only one. So this is change a lot, right? And so you could see that the data, okay, they have a very, very huge data. But now their card transaction, analysis, it can support more than 160 dimensions. That means it can support their user to drill down to detail. They can analyze at the transaction level. So that is totally different. And also, we help them to reduce the time to market from 4 days to just half day. That supported their business very much. Okay, so this is the first case. So the second case is from China Merchants Bank. Their use case just published through our website last 2 days. And so, first scenario is also replace the IBM Cognos, but now they are building a data as a services platform. This platform is a unified analytics layer for the China Merchants Bank, and they bring all the user scenario on top of that platform, from audit, from accounting, from fraud detection, from AUM, from a credit card transaction, and from customer loyalty and something else. More than 80 applications are landing over there. And consulting, they have about more than 300 million unique users. So think about that, how big that data is, right? And they are also using we call it a multi-tenants deployment. That means just the one instance, it can serving for the different organizations inside their group. Okay, and now we are reading data mainly from Hadoop. But now they have several use cases wanted to offload from the EDW side. Okay, so it's very great. And we support most of the BI intelligence BI tools, MicroStrategy, Cognos, Tableau, and also a Superset, and some in-house reporting tools they have. Okay, so this is already be nationwide, and it is a unified data as a service layer. Okay. Then on top of that, there are the different applications like CRM and I don't know others. Okay. So today's takeaway I would like emphasize here is the augmented OLAP will be the future for the analytics. This is because we reduced a lot of human efforts. We let a machine to do the machine job, right? And let people, those people will be released, and they should more focusing on the data management and governance, right? They are not a team to serving for the business user. They are a team working together with the business user. Because they will challenge the business user. Okay, here is why you export so much data last week, right? Here is a policy. You are violating over that. Or here you build this like application maybe 3 months ago, but based on the usage, that nobody use that. You are wasting time, wasting storage, right? So you should reduce that. This is what IT people they should to do, right? They should not. They should never be a person to take the requirement and to do the data cleanup and the transaction and build the report and give the business user, right? Always be complained, right? But never being given the credit, right? So that is we call it augmented OLAP. Okay, so yeah. Thank you very much, and here's my contact information, and feel free to contact me for any question. And we still have a little bit of time, right? Yeah. Do you have any question?
Can you use Kyligence OLAP for import and Power BI?
Yeah, you can. Yeah. So for Power BI, you're actually very easy. You just need to find a connector over there, and just put the server information and the user information, and it will pop up all the data models available for you, and you can just drag and drop.
General available connector.
Yeah, you are right. So using Kyligence, your people do not need to know any about Scala or big data or any programming code. The only thing you need to know is about the SQL, right? Yeah, and also Excel. So if you are using Excel, it will be a very great service. We offer the MDX services, so your Excel users can easily to connect to our MDX services and play over there, and can interact over say billions rows, 10 billion rows very fast from Excel side. Yeah. Mm-hmm. Any other question?
One question. So usually, maybe it's a stupid question regarding OLAP, but usually when we talk about caching or aggregation,
yeah,
there comes a next question or the next challenge is what to do with updates and what to do with the stale data.
Good.
So okay, it's fine to have an aggregation, but what if the data is already changed? So I'm looking at the old stale data.
Yeah.
Or what if I have a shiny cube with 100 billion records, but 100 records were changed?
Yes.
Now I have to recompute all the cubes. So how do you deal with that?
Okay, good question. So first, most of the cases, they actually are very, we call it a fixed scenario. That means you just need to refresh that data like a T+1 is good enough, right? So that means we can using the incremental load. It's like day by day. Most of the cases can serving for this one. But for some streaming case, right, it will change say just a half hour ago, but we want our analysts can access data, right? So there's a different way. So one way is when your source be changed, you definitely know when it will be changed, right? So it can trigger something and let our system can to change the data and to refresh that part. Okay, this is one way. And another thing is we can serving you, say a Kafka or other streaming source. So you can put such changing data to this streaming way, and we can pull over there. And we support update. We can support delete. So it just need to take a little bit of time to calculations for that. But yes, for today's architecture, it will have a little bit gap between when you change that data to the analysts can see that, right? But we are trying to reduce this gap very much in the next generation. Yeah, it will based on that the data. Yeah, but The key point is how you fire a CDC event, right? Yeah.
Okay, thanks.
Welcome. Yeah, you have a question?
Yeah, basically, what's a big size you can build on this top of Kyligence?
Okay. So the question is, what's the biggest size of the cubes cube we have? So let's talk about two things. First is from an internet company. We call it a Meituan, which is how say O2O company. Okay, they do like e-takeaway, like something like a Yip. Okay, and a lot of others. So they built a Kylin platform counting over petabyte data already, and one of that biggest one is already over like trillions records. That means they have a table counting trillions records, and they build the cube on top of that. But the most of the cycles is just less, about like 1 or 2 seconds. So this is one case, and another case is from I can tell you is from Prudential. Okay, you know Prudential, right? It is an insurance company here, right? So we just done a POC for them, and previous they cannot analyze so many data. But just within 2 days, we help them to do a POC using one cube contains 8 years data. 8 years data is within one cube. And their analysts just using like the Tableau to interact with that very quickly. Yeah, so that is the biggest we have. And since we are using the Hadoop, the distributed system, so the limitation is actually just by your cluster. And the good thing is, if you think that cluster cannot, serving for such like a big data, it's easy to just add several nodes is good enough. Okay. Okay. Any other? Yeah.
Just in terms of like one of the questions regarding updating cubes.
Yeah.
You were saying that you would have to something externally loading would trigger.
There are 2 ways. Okay, so the first way is we call it event trigger. So whatever system is, the upstream will trigger the refresh API for The second is we call it the scheduler. So you can using any like a schedule system to trigger that way, right? Yeah. Mm-hmm. Okay. And for example, we actually have one very special case. It is happen on the Google Cloud. So we using a file as a trigger. So that means we will monitor one like a folder, and they will put the indicator to that folder, right? And once that indicator generated in that folder, we will start to trigger the process. Yeah. Mm-hmm. Yeah. Okay.
Okay. Any other questions? No? Then we
Okay.
can close the session. Thank you very much for your presentation. It's really interesting what you were explaining today. So with this session, we just close. Remember that there is an event today in the evening. Okay, so enjoy that and see you tomorrow.
Okay. Yeah. Thank you very much.